Our presenter today is Ken Gregory. Ken is a professional engineer. He has over 35 years experience, engineering experience. He's worked in the past with Schlumberger, Gold Petroleum, Amoco, Scepter Resources, and for about 15 years, I guess, or so, with GLJ Petroleum Consultants, where he became manager of engineering with that group, dealing mainly with the oil industry. Correct? In 2005, Ken joined the Friends of Science Society. He's currently a director of the society and also a webmaster, which I guess you handle the information on the web.
Friendsofscience.org.
Oh, okay.
Yes.
Do you have any Russian connections? Or? Ken also writes for a newsletter for the client, or writes the climate science newsletter, as well as contributes to their quarterly newsletter for Friends of Science website. He's a mechanical engineer, a graduate of the University of British Columbia, and he's joining us today to talk about thoughts on our new climate leadership plan and determine whether or not it's a benefit or a burden. So please join me in welcoming Ken.
Hello everybody, and welcome. And thank you very much to Derek for that introduction and for inviting me to speak here today on the Alberta Climate Plan, a burden with no benefit. Of course, no. And I said I'm a retired engineer. I studied climate science for about 10 years, so I encourage you to visit our website at friendsofscience.org. We distributed three pamphlets. One indicates, talks about our society and other issues, and this other one is an 8-page pamphlet which talks about the Alberta Climate Plan and the science behind it. Okay. So it's all about climate, of course, and the climate scare that's going on now. So we'll first look at the satellite era, global lower tropospheric temperature and CO2. The blue line here shows the temperature that's measured by satellites from 1979. You can see lots of variability, but in fact the temperature changes or rise is quite small. Note that the distance between the horizontal lines represent only 0.2 degrees Celsius. You can see here these peaks here are El Nino events, and they're generally followed by cooler La Nina events. There are tropical ocean oscillations, and there's also cooling events there caused by volcanic eruptions. The green line represents the CO2 concentration. You can see it has increased, say from 1980, from around 340 parts per million to over 400 parts per million. Now 400 parts per million is equal to 0.04%, so CO2 is a trace gas. Looking at a longer time scale, the blue line represents the global annual temperatures as measured by weather stations, as well as ship data and ocean bores. You can see that there is a clear cycle up, down, and more or less flat. So these are also ocean oscillations. The red-brown line is the average of about 32 climate models. They were basically developed in the 90s, and they are tuned to match that rise in temperature from 1975 to around 2000. You can see there's a period of time from 1910 to 1940 in the blue line. There's quite a strong temperature rise. This is when CO2 concentrations went up only a very little bit, so this rise is is almost all natural. The climate modelers, of course, tune all this back history to try to match it as best as they can, and they use several parameters, but aerosols are the most important fudge factor, shall we say, or thing that they can adjust to try to match the past history. But since 1998 or so, we have a wide divergence. And as I showed in the previous graph, of course, this last uptick there is our most current El Nino, which is now ended, and now the temperatures has dropped right back down again.
Ken, on that, okay, can I ask a question as you go along, or should I wait?
I'll give you the opportunity, but I'd like everybody else to hold their questions until the end.
I was just noticing that from 1910 to 1950, and then from 1970 to 2000, it's about the same slope of increase?
It's about the same slope, yes.
Which means it's the same rate of increase
Right.
in CO2.
That's right.
Okay.
Right. But the earlier slope was due to natural climate change. So the issue is how much of the second slope is due to natural climate change. Looking at longer time scale, this is 11,000 years. So on this side, there's the end of the last glaciation. This shows the temperature fluctuations during the Holocene, which are fairly substantial. You see Holocene climate optimums, the Roman warm period, then temperatures fell into the Dark Age cold period, increased during the medieval warm period. During these warm periods are periods of great advances in civilization, great cathedral buildings during the medieval warm period. And then we plunged into the Little Ice Age. So during the Dark Ages, and especially the Little Ice Age, were characterized by famines and more disease. And now we're currently in the current warm period. All governments seem to have, they rely on summary reports for the IPCC, which is the Intergovernmental Panel on Climate Change, and they write reports on human causation of climate change. These reports are to support the Rio Summit for the United Nations Framework Convention on Climate Change, which was signed by most governments in 1992. That's a long time ago, really long, before a great deal of work has been done since then on both natural climate change and human causation. So the reports essentially ignore natural climate change. They're based on models that do not include natural causes. In 1979, there was made a report called the Charney Report, which estimated the equilibrium climate sensitivity, or ECS, to be likely in the range of 1.5 to 4.5 degrees Celsius for when you double CO2. But equilibrium means you double CO2 and then hold it steady and wait for the oceans to reach temperature equilibrium, which can take 2,000 to 3,000 years according to the climate models. So keep that in mind when you see equilibrium. Now, since that, what's this? 34 years, the latest IPCC report called AR5 also said the equilibrium climate sensitivity is between 1.5 and 4.5, exactly the same. So there's really been no progress from the IPCC point of view. The main purpose of course, the reports is one, to give them power, because of course when you control energy and you control the world and nations, but perhaps more importantly, is to distribute $100 billion per year via the UN Green Fund from industrial countries to other countries. And the other countries, of course, are many, many more than the industrial countries. So obviously, they want the UN to scare the heck out of people. So this graph from NASA shows their GISS temperature index. The black line shows the temperature index as per 1981, you can see a quite a large increase up to 1940. It's for the northern hemisphere, and then a significant drop. Well, because when I was going to university, all the major magazines, news outlets were indicating that there's a consensus of opinion that we're entering into a major cooling phase, and there's great concern that, that cooling would lead to widespread famine. Now the red line here shows the most current information. Now the temperature measurements from all the weather stations, of course, haven't changed at all, but you can see that they've reduced the temperatures of the 1940s so that it better matches the climate models. And there's many, of course, tricks that they can do to do that, and all these are revealed in the ClimateGate emails. Okay, so this graph indicates the temperature of the bulk global atmosphere temperatures. The red line is the average of the climate models. There's 102 runs of the various climate models. The circles represents the weather balloons, which are set up in the atmosphere. Okay, so we're taking the average of a bulk of the atmosphere, and the green squares is the average of the satellite data sets. So on this global basis, you can see that the model trend is about 2.5 times reality. So this is a huge discrepancy. Here is another graph, but now I focus on the tropics in the narrow range of atmosphere in the mid-troposphere. Here this discrepancy is even larger, to about 4 times. In this graph we're actually showing the individual runs, and you see they're kind of really all over the place. There's quite a range. The red line is of course the average. Again, the blue squares is the satellite data set, and the green circles are the weather balloons. Now, just looking at global or topical data kind of smooths out the discrepancy and hides the discrepancy when you look at the by latitude ranges. So on this side is of course the South Pole, Equator, and North Pole, and here instead of showing temperature, we're showing degrees Celsius per decade. So this represents the rate of temperature change. The blue line is the sea surface temperature. And you can see in the equator region, the rate of rise is about 0.05 Celsius per decade, very small. And the dashed red line is the average of the models, and they show great and much higher. In the southern ocean region, around -60, there's been a significant cooling. And this is over the period of 1982 to the end of 2014. So this is a long period of time. Now, instead of cooling, of course, to see the climate models show warming, and in the northern area between 60 and 70, there's been warming more than what the models indicate. But the CO2 concentration, of course, is the same in the south as in the north. Well, we'll show later here that this warming in the north is more related to aerosol effects. Okay, now to put these temperature changes in perspective, see how important it is. This graph shows the Alberta maximum temperature in red. That's the top line. And of course, it's been very constant at around 40 Celsius. This is the maximum temperature anywhere in Alberta over this period of time from 1990. The bottom line shows the minimum temperatures. Now, the urban heat island effect, which we'll get into here, very largely affects low temperatures but not high temperatures. So you can see there's a slight rise in the low temperature, averaging we're about minus 55 degrees Celsius. But on this scale, we're also showing the global temperature, which I showed earlier. HECLED 4 is a temperature index done out of the UK, and you can see in that, you can hardly see any change at all. Maybe the thickness of the line. This is the Canadian climate model. This is where your tax dollars go. The black line indicates the trend from the Canadian climate model from 1990 onward. The red line shows the satellite data, and the orange line is again the surface temperature, but we've adjusted it to account for the urban heat island effect. Now the corrected surface and the satellite data have almost exactly the same slope over this time period. But of course the key here is that the model trend is 4 times the observations. That obviously is a huge discrepancy. Now because I presented evidence here that the models are running way too hot. So why is that? One of the big reasons is water vapor, where water vapor is about 5 times more important than CO2 in terms of the greenhouse effect. So climate models all assume that relative humidity stays constant. And this graph shows relative humidity from 1965 onward at different levels in the atmosphere. The radar data shows that the upper atmosphere relative humidity declines with warming. At the 300 millibar pressure level, which is about 9 kilometers altitude, that's shown in the blue line. So you can see that has a significant downward trend during cooling. So of course from here onward there hasn't been much cooling, much warming, so it's flat. The bottom curve shows the relative humidity at the 400 millibar level at about 8 kilometers, and you can also see that it's declined. Now why is this important? It's because a change in water vapor at about 11 kilometers altitude, so high in the atmosphere, has 80 times the effect at the same change of water vapor near the surface. So water vapor, and even CO2, water vapor in the upper atmosphere is extremely important in regulating temperature of the Earth. Black soot on snow. Greenland and Arctic's snowy surfaces and ice have been getting darker over the past 2 decades. So the Arctic has warmed about 1.6 degrees, and the dirty snow may have caused 0.5 to 1.5 degrees of that warming. Okay? Now the direct effect of carbon dioxide is fairly easy to input into a computer model, whereas of course natural climate change is not easy. So the IPCC says that when you double the CO2 concentration in the atmosphere, and of course you wait 2,000 to 3,000 years, the temperature will rise by 1.1 degree. Okay, that's the direct sensitivity of carbon dioxide. But the models, on average, multiply that by a factor of 3 by adding in positive feedbacks. That is, they say that when you increase water vapor, increase the temperature, I should say, it causes the water vapor in the upper atmosphere to increase. But in fact, we know that doesn't happen. So the models add another 1.1 degrees Celsius as a water vapor feedback, when in reality it's much less. Now I could spend an hour talking about clouds, but the models show that clouds also cause a positive feedback. And in fact, when you add more water vapor, you get more clouds which reflect sunlight and reduce the amount of sunlight. So the clouds actually cause a cooling, contrary to the models. This is the Cortez ice core information over the previous interglacial, and it shows by the blue curve is the temperature. So the temperature has of course increased during the interglacial here and then decreased, but the CO2 comes up after the temperature increases. So why does the CO2 come up? It's because the ocean has warmed naturally, of course, and warmer oceans cannot hold CO2 as well, so they expel CO2, so the CO2 goes up. Now when CO2 comes up to the peak, when CO2 levels are high, well, according to Green's theory, you would think that would cause temperatures to go up even higher, but in fact when CO2 goes high, the temperatures drop. And when CO2 is low, here of course, temperatures rise. So that is something pointing out that CO2 is not the main driver of climate change. Otherwise, temperatures would continue to rise. That doesn't mean CO2 has zero effect, of course. Okay, so that's a quick overview of some of the basic issues of climate science. Now, for the Alberta Climate Plan, this includes the early phase out of coal-fired power plants by 2030, cap on oil sands CO2 emissions. We're going to cut methane emissions by 45% by 2025. And right now we have a $20 per ton carbon tax, which is going up to $30 per ton in 2018. At which time the carbon tax price effect would be $1.52 per gigajoule on natural gas and almost 7 cents per liter on gasoline. It's expected to generate about $9.6 billion of revenue over 5 years. Of that, we're going to spend $3.4 billion in subsidies to subsidize wind and solar, and that will then increase to $2.2 billion per year by 2032. Okay, the coal-fired power plant phase-out expected to cost about $31 billion. This is about $10 billion for replacement gas-fired power plants or conversions of coal plants to gas-fired. Then we were paying $1.4 billion for coal plant compensation for shutting them down. Okay, there's a cost of about $16 billion for renewables. It would be mostly for wind power, and perhaps up to $4 billion for transportation lines. So the cumulative increase of electricity costs, according to a major report done by EDC Associates Limited, is $3.3 to $5.9 billion. That's to 2032, and then $1.5 billion per year for 8 years. This assumes we're going to add 7,200 megawatts of renewable energy. Again, that'll be mostly wind. But as we're shutting down power plants, we also have to add gas-fired power plants for a total of 14,700 megawatts. Now, one of the reasons given by the government for shutting down coal power plants is health impacts of particulate emissions. The top graph here on this side, on the left side, shows the emissions of coal-fired power plants according to Statistics Canada or Environment Canada at 1,800 tons per year. The next is residential fireplace, which is double that. Then you can see agricultural, construction, and road dust. Now, forest fire is by far the biggest contributor, and you have to go to the bottom graph on a different scale. And on this scale, of course, the road dust, which is up there, is now just this little piece here. And of course, you can't even see anything for coal plants and fireplaces. You can see on the right, it's about 1.7 million tons per year. And the reason why coal plants are so small is because, of course, we have modern environmental equipment on it, fabric filters, which stop 99.8% of particulate emissions on many of our plants. So I'm going to talk about transient climate response. Now that is the change in temperature if you double CO2 at the time of the doubling. Okay? So if you simply extrapolate or increase the CO2 exponentially, it would take 125 years to reach a doubling. Now, in the last report, if we use the greenhouse gas forcings from the last report, and we use new aerosol estimates, and we look at the temperature changes over the last 153 years. This is from a paper by Curry and Lewis. That will give a transient climate response of 1.2 degrees Celsius. Okay, so that's 1.2 degrees change if you double CO2, which would take about 125 years from now. But of course that would be ignoring the millennium cycle warming, and of course we've seen that we're being warming here from the Little Ice Age. And also it doesn't take into account urban warming, so those warmings have to be subtracted to get a realistic number. So here's another graph of showing the millennium scale cycle. You see the Roman warm period, which decreases to the Dark Age cold period, medieval warm period, the Little Ice Age, and up to the current warm period. Well, everything up until 1900 would be natural. Okay, so from this you can see, we can easily calculate how much of the current warming is likely due to this millennium cycle. In the US, only about 11% of the stations are in suitable locations. NOAA, their major agency for this, actually publishes what the guidelines are, and only 11% of the stations meet that. 69% are within 10 meters of an artificial heat source. So here you can see where the thermometer is. This is a sewage plant, and there's air conditioner units pumping out hot air and here. And it's right next to this brick wall, which absorbs heat in the day and then radiates it and keeps the thermometer warm at night. So this is, of course, a very bad location to measure climate. A major study recently shows that 59% of the U.S. warming in the temperature index, NOAA and the NASA, is bogus. Here we've divided the stations into compliant versus non-compliant. The compliant stations show a temperature range change from 1979 onward. Now that, of course, is that major late 20th century warming, which of course is largely due to ocean cycles. Shows a trend of about 0.2 Celsius per decade. The non-compliant over 0.3 Celsius per decade. So what NOAA has done is they've adjusted the compliant stations up to match the non-compliant stations in the bad location. Then they increased it up a little further, up to 0.324 for their final adjustment. So this is, of course, a major issue. And this shows an urban heat island effect as you drive into and out of a city. This can be a 7 to 9 degrees temperature change. Of course, there are many studies about the urban heat island effect. One of them, done by McKittrick and Michaels, shows that almost half of the warming over land is due to urban development. GISS is the NASA temperature index, and they do presumably adjustments for this effect, but 45% of those adjustments increase the warming trend. Well, you're supposed to decrease it to eliminate the urban warming effect, but essentially it's essentially random. They increase the adjustments. Now, the IPCC, if you read the report, they agree with the Michaels and McKittrick and Michaels report that there's a great deal of correlation between urban development and temperature. Then they say that I quote, "The location of greatest socio-economic development are also those that have been most borne by atmospheric circulation changes." Okay, so what does that mean in IPCC talk? Okay, so Calgary is warm because of natural atmospheric circulation changes, but not the surrounding countryside. Edmonton is warm because of natural atmospheric circulation changes, natural causes, but not its surrounding farmland. So, like, would any scientist write that? Of course not. It's just IPCC nonsense. So, here I'll summarize the transient climate response. Again, remember that's 125 years. The IPCC says that's about 1.75, but they give a range of 0.9 to 3 degrees. However, that report shows what the greenhouse gas forcings are in the aerosol forcings and the temperature change. And when you use that from the report, you can easily calculate 1.33 degrees, which is, of course is in the peer-reviewed literature. So here I'm pointing out this huge discrepancy. So this is a discrepancy internal to the IPCC report. But since then, we've had new aerosol information. Stephen's paper, he's a world expert on this. When you use that, this number drops down to 1.2. And that reduces the high-end estimate. But then I've shown if you add in that millennium cycle, natural warming, and urban heat island effect, then that drops to 0.85. But the key here is look at the 95%. Why? Because all the damages occur at the high end. Okay? All these lower, if it was only 0.9 degrees in 125 years, that would be totally beneficial. So the damages come here at this high end, and that's 2.5 times too high in the report. So, a transient climate response of 0.85 will give about a 0.6 degrees warming between now and the year 2100. It's about 84 years. Assuming that you increase CO2 exponentially, extrapolated from current. Okay? So how do you get all these scare stories? Well, the IPCC produces what's called the RCP 8.5 emission scenario, which they call the high forecast. They don't call it a business as usual forecast, they call it high. But in fact, it's an extremely high forecast of emissions. Okay? So from that, and using their exaggerated climate sensitivity, they came up with 3.5 degrees temperature change between now and 2100. So in this forecast, the CO2 is increasing at about 0.55% per year, and they ramp it up to 1.2% per year. I don't really seeing that happening based on what all the governments are doing. It requires a tenfold increase in coal use by 2100. Population growth has been decelerating and expected to be stable before the year 2100. But this forecast assumes populations accelerate. About half of our emissions are absorbed by land and oceans. And in this forecast, the oceans, for unknown reasons, fail to absorb CO2. Matt Ridley is a famous science writer, and he calls it a barking mad scenario, as sold as business as usual. Okay, so now the government used this, something called the social cost of carbon. Well, it should be, of course, the social net benefit cost of carbon dioxide. And they use this top temperature distribution of equilibrium climate sensitivity. And you see it goes way up to 7 degrees. This graph here shows the range of a number of recent studies that were done. The top one, Bates, just done last year, it actually builds on the work of many other studies, and shows a very narrow range, which is quite different. This methodology is quite different from the next one, which is what I've already showed you. This here is about 1 degree of equilibrium climate sensitivity, or 0.85 transient response. So it's a very narrow range, and it's nowhere near this. These are others, but none of those include corrections for the urban heat island effect or the millennium cycle. So a huge discrepancy between the reality and what the US government uses to calculate the social cost of carbon. The US Interdepartmental Working Group on Social Cost of Carbon, the IWG, used 3 economic models called Fund, Dice, and Page. But the Page and Dice model have no CO2 fertilization effect, which is a major benefit. The Dice model assumes that the optimum temperature for humans is in about 1900. But the warming since then has been very beneficial. And the Page model is essentially a what-if model, and it uses an uncalibrated probabilistic damage function. It explicitly does not include adaptation, which grossly exaggerates the social cost of carbon. What it means is, despite how much warming you get, people will continually build their mansions right next to the ocean and don't take any steps to prevent damages. Nor do farmers change the strand of crops they use if temperature rises. Here's the DICE model projection of sea level rise to 2300. Look, it increases dramatically. Below, in the blue line, is the climate model average. But I've already shown you that the climate models are overwarm the Earth dramatically. So I've added this blue line to this graph is expected, and that's using a climate model emulator called MAGIC. And you see, so that's the realistic expected sea level rise, far lower than what the DICE model is, which the US government used. So if you buy the 0.85 transient climate response, the Fund model, the only model which includes costs and benefits, the other 2 models don't include either fertilization or benefits of warming. We expect a net benefit, net of cost, of about $17, or a social cost of $17, and a likely range of $19 to $12 per ton. So the chart in below, of course, shows the likely and the extremely likely range. So there is a range of probability, but the government uses social cost of carbon to set your carbon tax, which would be right over here, right? Be plus 30 rather than minus 16. Sorry, this is in US dollars, so minus 16 would be about $22 Canadian. The Fund model shows that in Canada, the net benefits of CO2 increases throughout the 21st century. And using the default values in Fund for climate sensitivity, they show a net benefit by the year of 2100 of $186 billion per year. Okay, that's the Fund model developed in the UK. The only model in the world that considers costs and benefits. These models used by the IWG forecast that the income per person in 2100 will be 5 times what it is today. So we're all becoming wealthier and wealthier with time, despite the warming. So carbon taxes actually transfers wealth from us, poor people, to the extreme wealthy people in the future. Right now, the carbon tax, of course, increases the cost of all goods and services, which is regressive and hurts the poor, but benefits all the crony capitalists in Edmonton out there with their hands out saying, "Give me subsidies, give me subsidies." So compared to the business as usual case, our climate plan will reduce the CO2 concentration by 0.026 parts per million by 2030, and reduce global temperatures by 0.00007 degrees Celsius, which is obviously insignificant and undetectable. So the IPCC, of course, ignores the sun as a driver of climate change, despite over 1,000 scientific papers published between 2004 and 2016 that are skeptical of the IPCC position. That is, they see the sun and ocean oscillations as major drivers. The IPCC ignores 123 peer-reviewed papers published 2008 to 2012 that shows the sun as a major driver of climate change. And there were another 320 papers published since then which shows a strong sun-climate link. So the sun is reviewed has in their reports, they make some comments about some of these papers, and they agree that there is a strong correlations between sun and climate. And they reply, the forcing from the changes in total solar irradiance, which means the heat output of the sun alone, does not seem to account for these observations, implying the existence of an amplifying mechanism. What that means is, the IPCC is saying specifically that the sun drives climate much more than just what can be explained by just the heat output of the sun. In fact, we know that the sun has a strong effect on clouds. After they say that, of course, it's completely ignored for the rest of the report, and of course never makes it into the summary for policymakers. So here is one example of correlation between the sun proxies and temperature proxies. The top curve indicates a solar proxy, and the bottom curve indicates temperature over a 3,000 year period of time. And you can see they go up and down very much in step. The bottom graph here is just simply a blow up of a portion here, which you can see has an excellent correlation. On a more recent time scale, here's the last 400 years. The dark curves are total solar irradiance, so we can think of that as a proxy for total solar activity. And the lighter curves here show the temperature. So you can see here, of course, we had low solar activity in the Little Ice Age, and we come up and down. And there seemed to be a bit of a gap here, but you can see that the solar activity has increased enormously during the 19th century. This is a solar magnetic flux. It's a solar magnetic flux which is really responsible for much of the climate change. A more active sun means you got more solar wind, more magnetic flux, which shields us from cosmic rays, which has the effect of creating more aerosols, creating little tiny particles to lump together, which will seed clouds. So the lack of this would cause less low clouds and more sunlight to come to the surface to create global warming. You can clearly see here the 11-year solar cycles, and the peak of the magnetic activity is about 1992. You can see there. That would cause probably a peak effect of this 10 years later due to the large heat capacity of the oceans. Now, what about extreme weather? Well, this top curve here shows the global hurricane energy from 1972. You can see lots of variability here, but there is certainly no trend and no real correlation to CO2. The bottom curve is for the northern hemisphere. In fact, the highest hurricane activity was in the Little Ice Age. Now, certainly heat is one of the factors that affects hurricanes, but there are many others. Tornadoes? Well, tornadoes require a cold front colliding with a warm front to create, of course, thunderstorms, and if you get everything just right, that will create a tornado. But the northern warming makes tornadoes less likely, and so you can see decline in tornado activity. Droughts, well, the Global Integrated Drought Monitoring and Prediction System here breaks droughts out by color in the intensity, and expecting to see a slight downward trend in droughts. So what are the benefits of warming? Well, I think you all know that, right? Longer growing seasons, greater area of arable land, lower heating costs, fewer cold-related deaths and illnesses, lower costs of outdoor activities such as construction costs and road maintenance, and the reduced tropics to pole temperature gradient. That's what feeds power storms. So reducing that to create fewer severe storms, which is what we see in the data. But the big issue here is CO2 is plant food. The CO2 increase since 1950 have enhanced crop yields by about 16%. And a 300 ppm increase of CO2 would raise the productivity of woody plants by about 50%. A major study has shown that CO2 fertilization has added about $3.8 trillion of value to the global crop yields from 1961 to 2011. That is a huge benefit. And this study here was done in just last year. You can measure leaf plants area by satellites. This study shows that CO2 fertilization caused about 70% of the leaf area greening trend from 1982 to 2014. And that's greening was over about 11% over this 33-year period. This is equivalent to adding a green continent twice the size of mainland USA. In the UK, death records show that cold kills 10 times as many people as heat. And the death rate in Canada is about 100 deaths per day greater in January than in July. And a major study over 13 countries shows that cold weather kills 20 times as many as hot weather. This is all compared to, for each country, what the optimum temperature is that causes the lowest death rate. Here's wind, Alberta wind. Okay, so the red line at the top shows the wind capacity during the first 3 quarters of last year. Look at that extreme variability. Many times, of course, the wind is zero or near zero. But of course we need electricity all the time, so you need 100% backup. But the problem with this huge variability is not just that, it's that existing power plants have to ramp up and down in mirror image to this to compensate for the wind variability. That huge ramping up and down causes, our power plants of course use spinning reserves to compensate that. That is, the generators are spinning but not at capacity. So this increases the amount of fuel use per megawatt hour of power generated. The Southern Alberta Transmission Reinforcement Project costs about $2.5 billion, and this is just to service the wind farms. The transmission costs are maybe 2 to 3 times greater than for conventional power. In Ontario, the feed-in tariffs are 12.8 cents per kilowatt hour, and my NMAX charge was 4.3 cents. So you can see that that wind farms are much more expensive than conventional power. They also kill bats and birds. Wind farms kill at least 1.5 million bats and birds annually in the US. The Ontario feed-in tariffs on rooftops can range up to 24 cents per kilowatt hour. For non-rooftops, the feed-in tariffs is about 21 cents per kilowatt hour, which is way higher than my energy charge. It's about 9 times higher than cost in Alberta. But recently, Ontario has approved a 20-year contract at 45.7 cents per kilowatt hour for a new solar project, or 11 times the INMAX. So the problem with wind or solar, of course, is that we are far, far north. The energy is extremely diverse, and the load factor is around 15%. So this is the power costs in Europe. The bottom axis shows the solar and wind capacity. You can see Hungary on this side here has very little solar and wind capacity, so they have the lowest power cost, around 12 cents per kilowatt hour. And in Denmark and Germany, they have very high solar and wind capacity, and they have the highest power costs. So in summary, carbon dioxide is a wonderful byproduct of fossil fuel use. The social net benefit of CO2, net of all these costs, is about $22 Canadian per ton. And the expected warming by the year 2100 is a trivial 0.6 degrees Celsius or less. You don't want to subsidize wind and solar. The climate plan is expected to cost around $31 billion for unreliable power to reduce temperatures by 0.00007 degrees Celsius. The plan will be a burden with no benefit. So I invite you to visit our website at friendsofscience.org. Thank you for your attention.